Hello, everybody. I will start my today's coding practice. Okay, so today's question is this one. So, backspace string compare. So, given two string s and t, return true if they are equal when both are typed into empty text editors. They're equal when both are typed into empty text editor. Sharp means the backspace character. Note that after backspacing an empty text, the text will continue empty. So, because this is an easy question, let me think of this question without seeing an example. Okay. So, I'm also typed into empty text editors. Okay, so I think what I can say is say with this one because okay, so in this case I type A, B, and then delete B because sharp is a backspace, and then I get C and D. So it will be ACD. And say if I get this one, I will type ADC and then backspace, so I lose C and D. But after that, I get CD, so it will be ACD. So in this case, these two, I mean, text is the same. Okay, yeah, exactly my understanding. I mean, examples tells that my understanding is correct. I will. Okay. So one question I'd like to make for the clarification is what should I do if I get A, B sharp, sharp, sharp? Because, oh, okay, let me do it. A sharp, 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 because, sorry, A sharp, sharp. In this case, A is deleted with the first sharp, but the second sharp has nothing to delete. So in that case, I guess, yeah, because if the string is empty, if I put sharp, let me show with this example. So I'm at the first position in this editor, and if I put delete, oh sorry, I have nothing to delete and nothing happens. So in this case, I think I should get just an empty string. So this is one of the clarifications I wanted to make. And aside from that, yeah. Oh, so what? Okay, both type it and empty. S and T consist of only alphabetic, yeah, lowercase letters and sharp only. Okay. Yeah, so I think I can use the stack. So yeah, simply saying, I will delete the element which is typed last. So last in, first out is the best, data structure I can use. So what I should do is build the stack and do the operation for S and get the remaining stack. And then for T, just I will do the same thing and I will get the final stack. And I compare these two stacks are the same. And if they're the same, I can return true. Otherwise, I will return false. Okay, so let me write the implementation. So let me write the because I will do the same thing twice, I will put it in the method. So what I will do is as stack is final stack S and do the same for T. And I will compare that if they're the same. I'm not pretty sure if this works in Python. Yeah. So yeah, for now I will go with this. If this doesn't work, I will, you know, implement it by myself to compare two stacks. So what I should do is here is wait a minute. So if char is only if there's a traceable character, I will pop it. And if the char isn't sharp, I will append it to this. Then I will return stack. Okay, let me confirm it again. So yeah. So let me think of this final stack method with a sharp a. So in this case, first three stack is an empty, and the first character is sharp. But for sharp, because length of the stack is 0, I don't do anything. And then I will go to the next character a, and because in line 31, character isn't sharp, so I will go to line 35 and append it to the stack. So stack has only a now, and I will return it. Okay, and just in case, if I have one more character sharp, what is expected is this, and in this case, the last sharp, for the last sharp, in line 31, because this is sharp, and length of the stack is now 1, so this is true. So in line 33, A is popped out from stack. Then in line 37, I will return the empty stack. Yeah, this is as expected. And I covered all the lines in this method, so I'm pretty sure this method implementation is okay. And I will go back to the bugs main method. And yeah, I'm pretty sure this three line method is correct. So I run my code. Good, and I will submit it. Okay, so the time complexity should be assuming that the length of string s is s and length of the t is t. Time complexity should be s plus d. Because I first recreated the stack, it took s for string s and t for string t because I took a look at every element, every character of the original string. And in line 26, I compared two of them. This takes the yeah, if the lengths of the stack are not the same, it will finish immediately just by take a looking at the string stack lengths difference. But if they're the same, I will take a look at every character in S and T. And because S and T ranks are the same, it should take S equal T time. Yeah. So in total, it will take O of S plus D. And for the space complexity, because I created two stacks, it will be S plus D. Because if there isn't any sharp, the created stack for S should be exactly the length of S. And samely for T, it should be the length of original string T. So in total, it will take S plus D. Okay, so that being said, there is a follow-up. Can you solve it in over one time and over one space? So I guess this means that I shouldn't take any extra space. So let me think. Yeah, I think I can use the two pointers. So I will move S pointer and T pointer at the same time. and one by one. And if I encounter the character which are not different, which are, well, sorry, which are not the same, I will return false immediately. No, it doesn't work with me. So what I mean to say is, sorry, what I wanted to say is, say if I have A, B, C and A, B, D, I can use the 2 pointers, but this doesn't work because if I have sharp here and C here, for three, A and A is the same and move point to this and this. But the problem is here, oh no, also B is the same, so I move each of the pointers. Then C and D are not different, but actually in string T, this D is popped out later, immediately later. Then C is appended. So actually there's the same strings in the end. Okay, so I think another kind of approach to work around this Backspace problem is that I track from the tail. So if I track from the tail, what happens is like this. I compare C and C, they're the same, so I move each of the pointers. And here I have the sharp, and so I can move it. However, and because this sharp cancels the next character, so I can simply say ignore count is now 1. And here I compare, oh, okay, so what I can say is, sorry, in S I find B, and if in T I find sharp, so I will keep going with ignore count 1. And then for D, this is ignored. Then I move it again. And but this should be now 0 because I ignored one character. Then here I find B. And there's the same. So I keep going. So I move the first point and second pointer. And now there's the same. So yeah, I finally reached, consumed all the characters at the same time. So I can return true. So this is the basic idea I can say. Yeah. One edge case I think I have to think is like this. In this case, I will take a look at B and B and A. That's the same. And then this point is moved to the index -1. However, for string T, this index is now moved to index 0. It seems like there's still remaining character here, but it's not true because the remaining is only sharp. So when I traverse it, I finally reach -1 in this, yeah, T. So I can say there's the same. So I will keep this in my mind when implementation, and I will start implementing. Okay, so this is the index in S, this is in T. And while I will keep doing until there is some remaining character and move aside. So what should I do? Oh, wait. And also another thing I have to take care is this case. So in this case, B and A is the same, so at the same time I reach, you know, index 0 and 0. And then what happens is that for each string, I find no character. So the implementation is a little bit, complicated, but I will try to think how I can simplify it. Yeah. So okay, so I will implement a kind of, iterator, char backward iterator. So okay, yeah, I will quickly write the interface only first. So this returns the next char or num if there isn't. So with this being said, what I can do is, wait a minute. So also I will implement the method. Yeah, okay. So with that being said, okay, so first tree S iterator should be char backward iterator S, and T iterator should be char backward T. Then what I can do is next is char and next T char. I can get it. Then what I should do is I will iterate this while both of them are, I mean, not none. In this case, I will compare them. So I will guess next char. Okay, and let me write the code first before explaining it. Okay, wait a minute, so I can say. Okay, so this is how it works. So in each of the iterator S and T, S iterator and T iterator, firstly in line 77 and 78, I will pick the first character. And then from here, I will do the while loop. And I continue the while loop until both of them are not none. I'm so sorry. Yeah. As long as both of them are not none. Yeah. But if each of them is none, it's time to finish. So I compare them. And if they are not the same in line 86, which means that each of them is known and each of them is some kind of character, so in that case, I will return false. Otherwise, in line 89, reaching here means that both of them are known, so I will return true. And in line 81 to 83, it is confirmed that next S char and next T char is not known. Both of them, each of them are not known. So I will compare them, and if they're not the same, I will return false. And in line 83 and 84, I pick up the next character. Okay. Yeah. I kind of have a feeling that I can maybe simplify this with me. So maybe. Okay, let me, I mean, refactor this code after I finish implementing the iterator, because yeah, I'd like to make this code work first. So okay, for this iterator, I define the definition that if I run out of the string, this iterator will continue returning, keep returning none forever. So this is the definition of my iterator. And here, wait a minute. What happens if this is in this case? I will delete this and this and sorry. So, yeah. Okay. Okay, okay, it's okay. Sorry. So if ignore count is more than one, but again I get say sharp again. In this case, this ignore count should be kept. Yeah. So otherwise, I will decrement the ignore count. Yeah. And also I have to make sure that I'm still in the valid index. Yeah. So when this is finished, there are two possible patterns. Maybe self-next index is already -1. In this case, I will return none. Otherwise, I will take a look at the current index position. That means ignore. Yeah, and I will return it. But I have to, decrement it. Yeah, so this is it. Okay, so let me check my implementation. So in line 71, if the next index is -1, which means that there isn't any more to see, so I will return it. Yeah. And if it isn't, I will take a look at I will look for the next character. So in line 74, I will initiate ignore count 0. And I keep continuing the next one. Oh, wait a minute. I have to skip the next in. I have to decrement the next index until this is still sharp. So what I should do is, so what I mean to say is, let me do it in this way. So wait a minute, what am I doing? So what I'm doing is I'd like to move the next index if it should if the current self.next index isn't the one to be taken. So if this is sharp, I still have to do it. Or if ignore count is larger than 0, I still have to take a look. Okay, I see. This should be and okay, so if next index is -1, I immediately have to finish this iteration. And in line 83, I return none. Okay. But if next index is still in the valid range, I will think if the next current position is sharp or ignore count is larger than 0. In either of these cases, I have to skip the current character. So in line 76, if it is sharp, I will skip the current next index and also ignore count. I will increment it. But if it otherwise, I will decrement the ignore count because, yeah, I can say this because larger than ignore count larger than 0 is already met here. And otherwise, I will just decrement the ignore count. And then I have to decrement the next index. And finally, in line 86, here, I find the next character to be taken, so I will return it. Also, I have to make sure that I move the next index by one. Okay, let me run my code. Oh, good. It worked. Okay. Okay, so my code worked. So yeah, I could implement the over n times but over one, constant space solution. Okay, so I finished my today's coding practice with. Oh, no, sorry. I still wanna refactor the main method. Yeah, actually, I think the importance, the priority to clean the code is almost always I should prioritize the refactoring of the main method over refactoring the sub method. So I will just refactor this main method and finish this coding practice. So what I can say is, so is the both of them are not known? Yeah. But if hmm, maybe this is good enough, I think. Yeah. Yeah, I think this is good enough. Yeah, I think yeah, this is good. Okay, let me take a look at the example code. Oh, this is much simpler. Okay, so I will take a look how I can write the code simplified like this. Oh, but I think basically it uses the iterator. Seems like it's almost the same idea, but much smaller code. I zip wrongest. What is this? So it seems like it uses iterator tools. Okay, so maybe this kind of stuff, and also this is its own okay method. Hmm. So I think this kind of internal, standard library method makes the implementation simpler. But I think my implementation is also good because when I take a look at the main method, it is clear what I have to do with the iterator, which is, split out as the another kind of helper class. Okay, so let me quickly wrap up my today's coding practice. So today's question was Backspace strings compare, and I firstly implemented it with stack. Yeah, and it took all of n space complexity. So, and then I used the iterator class as the second solution. The main idea was that I traverse the characters backward from the tail in each of S and T. Yeah, so that's it. Okay, so yeah, sorry, maybe I should call this next because this is more, ordinary name, common name in of the iterator. Okay, good. Okay, so let me finish my today's coding practice with this. Okay, thank you so much. Bye.